Swagtam, welcome back to the Mela Bhumakrak Kumar. I am Mela Bhumakrak Kumar and I am making video for FFCBMD. Now, today in this lecture, we will calculate the frequency of revolution of the electron in its orbit. So, for frequency is given by that is Fn frequency equals to a speed of the electron by circumference of the orbit, or Fn equals to Vn by 2 pi Rn, n for nth orbit. Now using previous equation we can calculate, that is using the value of Vn and Rn we can calculate the Fn frequency, like Fn equals to 1 by n into Ze square by 2 epsilon naught h into pi Zme square by 2 pi n square h square epsilon naught, or Fn equals to 1 by n square into mz square e to the power 4 by 4 epsilon naught square hq, or we can write Fn equals to z square by n square nq, Fn equals to z square by nq into m e to the power 4 by 4 epsilon naught square hq. And if we put z equals to 1 for hydrogen like atom, we get Fn equals to 6.6 into 10 to the power 15 by nq revolution per second. And now using the value of n equals to 1, 2, 3 etc, we can calculate the frequency for first orbit, second orbit and third orbit, so on. Now let's calculate the wavelength of emitted radiation. If an electron jumps from an outer initial orbit n2 of the higher energy level to an inner orbit n1 of lower energy level, the frequency of the radiation emitted is given by nu equals to E n2 minus E n1 by h. And from above equation we have E n2 equals to minus mz square e to the power 4 by 8 epsilon naught square h square n2 square, and E n1 equals to minus mz square e to the power 4 by 8 epsilon naught square h square n1 square. So nu equals to E n2 minus E n1 by h, and calculating we get nu equals to m z square e to the power 4 by 8 epsilon naught square hq into in brackets 1 by n square minus 1 by n2 square. Now the wave number, that is nu bar, of a radiation is defined as the reciprocal of its wavelength lambda in vacuum and gives the number of waves contained in unit length in vacuum. So nu bar, that is wave number, nu bar equals to 1 by lambda equals to nu by c, that is frequency by velocity of light, or nu bar wavelength, wave number nu bar equals to 1 by lambda m into z square e to the power 4 by 8 epsilon naught square hq into in brackets 1 by n square minus 1 by n2 square, or 1 by lambda equals to r into 1 by n1 square minus 1 by n2 square. That is wave number equals to 1 by lambda equals to r into in brackets 1 by n1 square minus 1 by n2 square, where r is called Rydberg constant, which is a constant, and for whose value is m into z square e to the power 4 by 8 epsilon naught square hq. Now for h, hydrogen, z equals to 1, so r equals to m e to the power 4 by 8 epsilon naught square c into hq, and using the value of m, e, epsilon naught, c and h, we get R equals to 1.097 into 10 to the power 7 per meter. That is, this is the value of Rydberg constant, 1.097 into 10 to the power 7 per meter. Now, wave number 1 by lambda equals to R into, in bracket, 1 by n square minus 1 by n2 square. Now we see the spectral series of hydrogen atom, that is the name of the series given by the discoverer.